Welcome to my channel. The fine-tuned universe, the idea that the fundamental constants and laws of physics are precisely set to permit the existence of life, has captivated scientists, philosophers, and theologians alike. At its core, the argument posits that even slight deviations in these constants could render the universe uninhabitable, leading to questions about coincidence, necessity, and the potential for deeper explanations. This article critically examines the fine-tuning argument while analyzing the scientific and philosophical challenges it faces. The fine-tuning argument arises from observations that certain physical constants and quantities, such as the gravitational constant, the cosmological constant, and the masses of elementary particles, lie within extraordinarily narrow ranges that allow for the emergence of complex structures, stars, planets, and ultimately, life. For example, if the strength of the strong nuclear force were even slightly weaker or stronger, atomic nuclei would not form as they do, preventing the formation of essential elements like carbon and oxygen. Similarly, a minute change in the cosmological constant could result in a universe that either collapses too quickly or expands too rapidly, precluding the formation of galaxies. The improbability of these precise conditions leads some to argue that the universe appears to be fine-tuned for life. This notion has gained significant attention due to its implications. It suggests that the universe is either the result of an extraordinary coincidence, a necessity of deeper physical laws, or the work of an intelligent designer. While the fine-tuning argument appears compelling, several analytical critiques challenge its premises. These critiques can be grouped into three main categories: probabilistic reasoning, naturalistic explanations, and philosophical objections. Critics argue that fine-tuning often conflates retrospective improbability with inherent significance. While the constants may seem improbably aligned in hindsight, this does not necessarily mean they are deliberately tuned. A classic analogy is that of a lottery winner. While the odds of a specific individual winning may be astronomically low, someone has to win. Similarly, the argument that the universe's parameters are fine-tuned often overlooks the possibility that we observe these conditions simply because we exist to notice them, a concept known as the anthropic principle. One of the most significant scientific challenges to fine-tuning is the multiverse hypothesis. If our universe is merely one of an enormous, possibly infinite, number of universes, each with varying physical constants, then the apparent fine-tuning of our universe may not be remarkable. In such a scenario, universes with life-permitting conditions would be rare but inevitable. The multiverse theory, supported by some interpretations of string theory and inflationary cosmology, suggests that fine-tuning may be an artifact of selection bias rather than intentional design. Philosophical critiques of fine-tuning often focus on its underlying assumptions. For instance, the argument assumes that life as we know it is the ultimate benchmark for evaluating the universe's properties. However, if the constants were different, entirely different forms of life, or phenomena we cannot currently conceive, might emerge. Thus, the conclusion that the universe is uniquely fine-tuned for life as we know it may reflect anthropocentric bias rather than an objective truth. Despite these critiques, the fine-tuning argument remains a subject of legitimate inquiry in cosmology and metaphysics. The interplay between physics and philosophy highlights the profound nature of the questions posed by fine-tuning. Are the constants of nature fixed and immutable, or are they determined by deeper principles yet to be discovered? Does the universe's apparent fine-tuning demand a designer, or does it point to a more expansive framework like the multiverse? From a scientific perspective, the search for answers continues. Efforts to unify quantum mechanics and general relativity may provide insights into why the universe's constants have the values they do. Similarly, advancements in cosmology may help us determine whether the multiverse is a testable and legitimate extension of physical reality. The fine-tuned universe represents a tantalizing intersection of science, philosophy, and existential inquiry. While its proponents view it as evidence of intentionality or purpose, critics caution against drawing premature conclusions based on current knowledge. Whether the result of coincidence, necessity, or something more profound, the universe's precise parameters inspire awe and compel us to push the boundaries of human understanding. Until we uncover definitive answers, the fine-tuning debate will remain one of the most profound discussions in modern thought, reminding us of the delicate balance that makes our existence possible.